those are the fermions are the ones that interact with each other. The fermions are the ones that emit and absorb these boson particles, and the bosons are the ones that carry the momentum.
Okay, gotcha.
Just out of the forces.
You said there's two theories. So what are those two?
So yeah. So after that, I'm gonna explain the forces carried by all the bosons. I'm gonna finish that.
Okay.
But so you have quantum electrodynamics and quantum chromodynamics. So with quantum electrodynamics, what is being explained, so they're similar theories, but they just describe different forces.
Okay.
So quantum electrodynamics describes particles that interact with each other through the electromagnetic force. So since the photon is the only electromagnetic boson, the only boson that carries the electromagnetic force, it's the only particle that's emitted between, exchanged between particles that interact only electromagnetically. Electrons, famously known, better known than muons or tau particles. Those are better known by people who actually take physics classes or particle physicists. But electrons, they of course interact electromagnetically. So using quantum electrodynamics to explain this interaction, they emit and absorb, they exchange photons between each other. And of course, since they have the same charge, they repel each other. But aside from that, quantum electrodynamics suggests that that it is the momentum of the photons that pushes them apart. So you have quantum chromodynamics aside from that, which describes the strong nuclear force. With quantum chromodynamics, it's the same idea as quantum electrodynamics, again with a different force. You have two particles that interact through the strong nuclear force. In this case, the quarks that compose the protons and neutrons. Not to forget, I forgot to explain this. This doesn't really matter, but it's to be specific. The proton is composed of two up quarks and a down quark, and the neutron is composed of two down quarks and an up quark. Just putting that out there. So so let me start with this question to explain quantum chromodynamics. How do these quarks stay together to make either the proton or the neutron? Both being baryons, but those aren't elementary particles, those are types of composite particles. Baryons are just configurations, they're just particles built from three quarks, composite particles.
Okay.
But so how do these up and down quarks stay together within the protons or the neutrons? So what they do is they of course pull on each other through the strong nuclear force. But in quantum chromodynamics, the same idea as quantum electrodynamics. According to quantum chromodynamics, these up and down quarks emit and absorb. They exchange gluons, the carrier bosons for the strong nuclear force. They exchange gluons, and that's how they establish the strong nuclear force. So getting back to the bosons, the photon carries the photon carries the electromagnetic force. The gluon carries the strong nuclear force. The Z bosons, the W bosons, and the Higgs bosons all carry the weak nuclear force.
Okay.
Which again is what neutrinos interact with. So the interesting thing is, and this is sort of off topic, not really, but it goes with how neutrinos interact with the world. Neutrinos are the only fermions that explain they're the only fermions that interact through the weak nuclear force.
Okay.
Not the quarks, not the electrons, muons, or tau particles, just those three neutrinos. So, you've heard that neutrinos can pass through any given piece of matter, right?
Yes.
So, why does that happen? Why, as part of the cosmic rays that bombard the Earth, why do neutrinos just pass through the Earth? So, as I said, the atoms that compose matter are composed of electrons, neutrons, and protons. But overall, those particles, when you break the atoms down to electrons and quarks, the quarks making the nucleons, you would have two forces that account for matter, that account for the buildup of matter, which is the electromagnetic force with the electrons and the strong nuclear force with the quarks. So the neutrino particles only, again, interact through the weak nuclear force, and they don't interact through interact through either force that that describes the particles that build up matter, the quarks and the electrons, the strong nuclear force and the electromagnetic force. So simply, these particles, these neutrino particles, don't interact at all with the matter, and they just pass through it without interacting with the quarks or the electrons.
So there's no forces slowing them down or putting them.
No,
So
there
there's
are no particles being exchanged between these. There's no momentum that's carried by any particle that, for any force that, that
that interacts with neutrinos.
yeah, that the neutrinos interact with, and the the protons, neutrons, or the quarks that compose them, and the electrons.